and lift off. So now we're doing section 6.3. It's day 4 for 6.3. It's day 3 for rotation, volume of revolution. So this is day 4 of volume. And today we're going to do revolution around other axes. That means not the X and Y axis. Okay, so for my first trick, I gotta turn this so I can actually write, because I can't write straight like that. For my first trick, we're going to do, so this is example 1. We are going to do the region defined between y equals square root of x. Sound familiar? Y equals 0 and x equal to 9. We've even drawn this cross section before, but now we're not just going to find the area, we're going to revolve it. We're not going to fill it, we're going to revolve it. But guess what you're going to revolve around? You're going to find that region and you're going to revolve it around x equal to 9 to find the volume. Okay, we should sketch it first. It's one of my favorite curves, right? So that should be easy. You should be getting good at this by now because it's all over the place. Square root of x. Y equals 0. X equal 9. Not to scale. This would be a y equal to 3, right? What is the square root of 9? 3. That's why I drew that on there, right? Makes sense? Everybody got a cross section. We are revolving this around x equal to 9. So what's my axis of rotation? It's this. Is that a vertical line? If I draw the cross sections, because the cross section is always perpendicular to your axis of rotation. So will my cross sections be like this? What is that perpendicular to? So what's it going to be in terms of? Y. My cross sections are perpendicular to the y axis. So therefore, if I look on the end, if I just look right here, if we look right there, do we see delta y? That's my hint that it's a with respect to y. Is the x equal to 9 the rightmost curve? Is the square root of x the leftmost curve? But is this in terms of y? No, this is not in terms of y. What do we have to do? Square it, and do we get x equals y squared? So this is x equal y squared. Does everyone see it? So if I pick one cross section, this is just one, that's my one cross section. What is my radius for that one cross section? What's the rightmost curve? 9. X equal 9, so it's 9. Minus, what's the leftmost curve? 0. So it's minus y squared. Everything's in terms of y. Do my cross sections touch the axis of rotation everywhere? Are there any holes? If I drew it in, would it touch? I didn't shade it all the way. Let's draw one cross section. Let's draw this green cross section. Right here, if I draw this cross section, that's my radius, right? So that means I gotta all the way out here, and this is the cylinder I'm producing. It's solid. Is there a hole in it? No. And if I look right there, is that delta y? Is this area equal to r squared times pi? Actually, let me rewrite pi r squared. Pi r squared, right? So am I going to stack them? I'm stacking these disks. What are my limits of integration? Is this A and this, or C and this D? Am I integrating from 0 to 3? Stacking disks from 0 to 3. Is this going to be a nil or wafer? When I draw this shape, is it nil or wafer? Yep. I'm hungry, can you tell? Okay, so let's go ahead and find the volume. My volume, I'm stacking pi r squareds. So it's pi integral. What was my lower limit of integration? 0 to 3, right? Of 9 minus, y'all are so confident about that. And I'm squaring this radius dy. Was that the hard part? Yes. The rest of it's easy. Is that going to be easy? Do you just have to square the binomial and then integrate the 3 terms? So let's do that. We have a pi. We are integrating 0 to 3. What is, if I do 9 minus y squared times 9 minus y squared, what's 9 squared? Okay, so I have a 9 times y squared and a 9 times y squared, so it's minus 18y squared. And then what's y squared squared? Y to the 4th. It's going to be a long day. What is the antiderivative of 81?
81y.
Oh, there we go. Now I hear your voices. Y'all can do easy.
We'll say it louder.
What's the, well, okay, but I don't need you to say it louder. I need to have more people say it, not just you. Right? What is the antiderivative of negative 18y squared?
6y to the 3rd.
So I'm going to get but it's going to be a minus 6y to the 3rd, yes?
Yes.
Everybody still with me? What's the antiderivative of y to the 4th?
Y fifth over 5.
And I'm integrating from 0 to 3, so you just have to do 3's. And you should be able to do these. So I got 81 times 3 minus 6 times 3 cubed, which is 27, plus 3 to the 5th. You can do it. Well, let's just do it. Let's just write it to the 5th. Don't worry about it. Over 5, right? Minus 0, because when I plug in 0, is it just going to be 0 for each term? Yep. All right. You don't have to simplify that if you don't have a calculator. You plugged it in. That's sufficient. We could play number sense games, but I don't feel like it. Okay. Was that not bad? I don't have a that's not bad button. I do have a why not button. I have a nose button. We got the nose. Would you like to see another one? You're gonna see another one. Because that was a disc. Could we do the same thing with a washer?
Sure.
Oh, sure. Sure we could. Oops, I need another page. These kind of take up a lot of room. Okay, this is example 2. This time, we want the same region. Why would I make you do a whole new one when I can use that same one many different ways? This time we're going to revolve it around x equal to 10. I want to revolve it around x equal to 10. So we're going to sketch the same region. We've got y equals square root of x, which is the same as x equals y squared, right? And then we have y equals 0. We have x equals to 9. That gives me a y equal to 3 here, and then y equals 0 there, yes? And we know our cross sections are perpendicular to the axis of rotation, which is parallel to this, but it's a different one. It's not x equal to 9 anymore, it's x equal to 10. But is this the region I'm talking about right here? Is that, oh, I have a better way. Here we go. Is this my region? This whole thing, yes? Is that my region? Isn't that pretty? And I'm going to revolve it around x equals to 9. Oh, sorry, 10. I meant to say 10. I put it in the right place. I just can't talk. Thank you. Y'all are listening. That's amazing. And y'all even said that confidently. Awesome. Does my region touch my axis of rotation anywhere? No, there is gaposis. Since there is gaposis, does it have to be a washer? It's a lifesaver. Gotta throw you a lifesaver. Yes, I do. Okay. Well, so going from the rightmost over here, is that my little r? And what is little r equal to? 10 minus 9 equals 1. Did I cut a cylinder out of this? So it's a Niller wafer, but now we took the Niller wafer and we drilled a cylinder out of it. Yes, I'm still hungry. All right, what's my other radius? My other radius is, what am I going to use? Oh, well, I might as well use blue again. Is it going all the way to the leftmost surface? That's big R. And what is big R equal to? The 10 minus what? This is x equal to y squared, right? Y squared. Oh, this is going to be much more interesting. If I draw a cross section, notice this is my R, the little r, and this is the big R. So does this have a hole in it? And then we have the big radius with a thickness, that's a delta y, and there's a delta y here. Do I have a hole in my, so is that a washer? It's a lifesaver. Do we have everything we need? Same limits of integration, right? We're still stacking from 0 to 3. Yes? Yeah, we are. Here we go. Let's write the volume. So my volume is equal to pi, because the integral of the outer part is pi r squared, and the little of the inner part is pi r squared. So it's pi is going to be the integral from 0 to 3 of my big R squared, which is 10 minus y squared squared, minus my little r squared, which is 1 squared, dy. You're going to have to square the binomial.
Wait, time out. Why from 0 to 3?
Huh?
Why from 0 to 3? Oh.
The region was defined.
Oh. So it's not like from, it's not from 0 to...
It's taking that region and revolving it.
Okay.
Don't make up any more. Do I only want this region? Does that region go to a y of 3, max?
Okay.
If x is 9, y is 3, you can't go any higher unless you make up more region, but that's not the region. This region only goes to y equal 3.
Okay.
All right, so now we're going to integrate, but first we have to algebra. So I got pi, I'm going 0 to 3. What's 10 squared? Still 100. That was oh my goodness. What is a negative 10? So a 10 times the negative y squared plus a 10 times the negative y squared, a negative 20y squared. And then negative y squared squared is going to give me plus y to the 4th dy.
And the 1.
Oh, huh? Yeah, no, it's minus 1. It's still minus 1. Oh, come on, eraser. Minus 1 dy. Right?
Yes.
Okay, so is that going to become 99? Pi integral from 0 to 3 of 99, yes, minus 20y squared plus y to the 4th dy. Antiderivative of 99 is what? 99y minus antiderivative of 20y squared. 20y. Anybody there? Okay, antiderivative of y to the 4th. Yeah, there I heard. Y to the 5th over 5. Yes? Evaluating from 0 to 3. And you don't have to evaluate it, you do have to plug it in. So you're going to end up with 99 times 3 minus, well, I got 3 cubed over 3, so that's going to be 9. So that's 180. You can do that one, right? Plus 3 to the 5th over 5, you don't have to evaluate it. Minus 0, and you're done. You know, if you don't have a calculator, you don't have to simplify it anymore. Fair enough? But wait, there's more. What if instead of everything being with respect to y, what if it's respect to x? What would that look like? I did 2 of the y's because that takes a little more practice and y'all haven't necessarily done it. So guess what my region is this time? It's between my other favorite curve and nice stuff. So what if it, actually it's between my 2 favorite curves. What if it's y equals x squared and y equals square root of x? And we're going to revolve it around y equals to negative 1. Find the volume. Sketching my curves. Y equals square root of x. Y equals x squared. My axis of rotation is down here. It is y equal to negative 1. This is what I'm revolving around. Since I'm revolving it around something that's parallel to the x-axis, does that mean all my cross-sections are vertical? I'm doing this region right here. Right? That's my region. And my cross-sections are perpendicular to the x-axis. So what's everything with respect to? Yeah, with respect to x. So let's draw the radii. Okay, here we go. I'm just going to go, what's this radius right here? Versus what is this radius right here? Oh, that doesn't work show very well. Let's do it from here. Here we go. That radius right there. So the little r is this, the big R is this. So little r is equal to what? This is y equals 0. What's little y? I mean little r. This one, so it's x squared minus negative 1, which means it's x squared plus 1. Remember how I said that's why I wanted you to write the minus 0 for right now? Because now it's something else. What's big R? Big R is what? Big R is for the square root of x, right? So it's square root of x minus a negative 1. So it's square root of x plus 1. Drawing a cross section. We just draw a cross section. So there's my little r. And then here's my big R. So the little r makes the hole. The big R makes the whole washer. It has a delta x. That's delta x. This also has that depth. So little r, right? So do I have just an area, a volume, so it's an area of the outer circle minus the area of the inner circle times the height, which is dx. So my volume equals pi integral. Okay, let's look right here. What are my limits of integration, by the way? What is this value? 1, right? So I'm integrating from 0 to 1 of big R, which is square root of x plus 1 squared minus little r, which was x squared plus 1 plus u squared dx. Someone let Ethan in. So what's the volume equal? pi, integral from 0 to 1. Okay, what's the square root of x squared? X.
Is medium okay?
Oh yeah, thank you. Tee-hee-hee. And then when I'm doing the inner term, it's 1 times square root of x plus 1 times square root of x, which means it's 2 square root of x's, right? And 1 times 1 is 1. Is that the first one? Yes, it is. Minus squaring x squared plus 1 gives me x to the 4th plus 2x squared plus 1. Put it inside of parentheses like that, because otherwise you're going to forget to distribute. Because do you have to distribute that? Does this negative have to need to go to all three terms? And is that a common mistake? Don't make that one, please. Move on to something new. B equals pi. And so I'm going to simplify because I don't want to integrate too many terms. Can I simplify a little bit? Yep. So I'm going to end up with, there was a 1 there. I lost my 1. All right, so what am I going to end up with? I'm going to end up with a negative x to the 4th because there's no other x to the 4th term. There's no other x squared term either, so it's minus 2x squared. There's a 1 here and a minus 1 there. The 1's going to go away, yeah?
Yeah.
Then I get plus x plus 2x to the 1/2 because I'm getting it ready for power rule. What is the antiderivative of negative x to the 4th? All right, what's the antiderivative of negative 2x squared? Yep, 2x cubed over 3. What's the antiderivative of a positive x?
X squared over 2.
Awesome. What is the antiderivative of 2x to the 1/2 power?
4x over 2.
Yeah, so 4x over 3. So it's 2x to the 3/2 over 3 times 2. And we are evaluating from 0 to 1. Is that going to be easy? So we got pi. When I put in the 1, do I get a negative 1/5 minus 2/3 plus 1/2 and then plus 4/3? Is that 1? Yes? Minus 0, is it just minus 0? And you don't have to, you could clean it up if you wanted to, but you don't have to. And that's